Hello, my name is Miranda Cal and this is lab number 4, oscillations. The purpose of this lab is to predict the motion of an oscillating spring, and the main result is that the predicted motion and observed motion are similar and the total energy change is zero. In this lab, the system is the spring and the mass, and the surrounding is everything else.
In this experiment, a lot of physical models were applied, the most basic one being Newton's second law, which states that the net force of an object equals the change in momentum over the change in time. And there is velocity updated formula, which relates velocity and the net force, and the position update formula. Other than that, there's kinetic energy, which is 1/2 times mv squared, and spring potential energy, which is 1/2 times k delta x squared, and gravitational potential energy, which equals m times g times h. This is a video recording from Tracker. I tracked the oscillating ball's motion by using this app, and it recorded its x and y position. I then copied and pasted all the data from Tracker and uploaded it in Excel. Here are the two sine graphs produced from Tracker. I put the x and y values produced from Tracker into a CSV file so the GlowScript code can read it. And this is a brief recording of my GlowScript code. I would like to draw your attention to the initial condition. I used the data from Tracker to edit the mass of the ball and its initial position. And then, as for the calculation, spring constant K was calculated by using the period of oscillation, which was calculated using the position data as well as the object's mass from Tracker. And then L naught was calculated using the spring stiffness value. And from line 92 to 98, I basically used what I mentioned on the third slide, which were all the energy laws, including the kinetic energy, gravitational potential energy, and spring potential energy, and then I added them all together, and that's the total energy. This is one of the graphs produced by my code. As you can see here, there is a lot of error for both x versus time as well as y versus time, but y versus time especially. One reason to explain this is that on Tracker, I had to individually place the dots over the object, which had probably led to a very shaky graph, as you can see represented by the red line. To answer the what does it mean question, I would like to say that yes, the energy principle was satisfied because the total energy remained constant, and you can see this in the graph. So the orange line, delta E, represents the total energy, and it states 0, which means that the change in kinetic energy cancels out the sum of the change in potential energy. To answer the second what does it mean question, I would like to address that the difference between the components can be attributed to the fact that there is more force, including gravitational and spring, in the y component than the x component, which will cause the object to oscillate faster in y direction. In conclusion, this lab applied energy principles to predict the motion of an oscillating spring, and some possible physical errors can be caused by air resistance and human errors in tracking the motion of the object in Tracker. Thank you.